Good morning to our dear viewers. You are welcome to homeschool program. We are so grateful that the Lord has kept us alive. We need to appreciate Him and thank Him for that. Okay? Every morning when you wake up, pray and surrender the whole day to the Lord. He will take you through and everything will be okay. We are grateful that the Lord has blessed our pastors, Pastor Jackson Senyonga and Pastor Eve Senyonga. He has given them a good heart to serve this nation. So they are the ones sponsoring this program. They're the ones who are paying for each and everything to make sure that our students continue learning. Kodai School is a school found in Seta Bajo, just off the main road, a few kilometers, under the leadership of Madam Shemerio Lydia. In case everything becomes fine, we end the lockdown, schools resume, please feel free to come to Kodai School and your student will be able to get the best education, both A and O level. Okay, all combinations are there. Please bring those students there. Today we are going to handle O level chemistry, as we started this week on Monday with a topic which was thermochemistry. So today we are going to add on. Your teacher is Saul Abooki. I've always told you, if you want to contact me, Facebook page Saul Abooki, reach there, like the page and send a message. YouTube Saul Abooki, can get all the videos and many other things. Twitter, can contact me at Saul Abooki UG. Contact number is there. Can also reach me for consultation. We can organize Zoom lessons, both O and A level, most especially the candidates classes. Can be individual, can be group. Okay, we do all those things. Allow me to greet a few people. I've always told you that when you wake up, the first thing you do, pray. After praying, greet the people you are living with. So I want to send my greetings to all mothers who are outside there, all responsible fathers, and all friends of mine. Okay? So today, before we start the lesson, make sure you have a pen, make sure you have a pencil, make sure you have a calculator, make sure you have a notebook, all right, and a functional calculator. Invite someone to study with you. For those who have been missing out some lessons, you have attended some, but other things you did get them very well, you can still get all the slides and copy the notes if you understood, or copy and look for explanation. For more explanation, you can read the textbooks, you can consult from friends, you can consult from those who have done these things before. Okay, so also you can check on top television page, you get the videos so that you'll be able to use them, or you can visit our website, which is www.kodaischool.ac.ug. When you reach there, you'll be able to get the work. But always I've tried, some students consult me and say, how can we get to the website? We have failed. So let us first have a look at that video. You reach there, it's the website. Just press there, get your Chrome. You reach there, you see here, there is that search button down. There is that one, but there is also access the website. Just press there, get your Chrome. You reach there, you see here, there is that search button down. There is that one, but there is also app. you click up and put in www.kodaischool.ac.ug. You search, you need to be patient. When you search, you get a display having Kodai School photos and everything. Okay, this one. You read up here, you see log in, sign up. Sign up is for creating the account. You click on sign up for the very first time. Click on sign up, allow the phone to search. Then you see registering for this site is easy. Just fill in the fields below and you will get a new account set up for you in no time. Account details, username, email address, choose a password. Pick any password, the best password for a student. You can get your telephone number and put there the first letter of your name. Okay, profile detail, name, put your full name so that we'll be able to approve your account. Phone number, class, if you feel class is required, put it there. Then you complete the sign up. When you press complete sign up, it will take you to the first display, and that is the first display. What you do, you have created the account, you say yes, you access the website, just press there, get your Chrome.
So I've been created the account. You wait for around 10 minutes because in the system we need to approve your account. So you wait for around 10 minutes, someone will approve your account, then you go back. When you go back, you have to use the password and the username you have created. Okay, so let us see the video of how to log in.
So when you search, you get a display. You need to visit the website. When you want to visit the website, you need to be with the website account. So assuming that you have the website account, you just need to click on your Chrome to bring for you such a display. The display is having the search button down, whether it's www.kodaischool.ac.ug, and there is another one up where it's google.com/search. So what do you choose? You have to click the one which is up here, the one which will take you to the website. You put in www.kodaischool.ac. You search. Okay. When you search, you need to be a little bit patient with your network, depending on the network you're using. So when you search, you get a display of Kodai School website. That is it. That's how it looks like. You scroll down, you can be able to see the photos and everything. Then you come up. You see, the other time when you are creating the account, you click on what they call sign up. But when you already have the account, or after creating the account, you need to wait for some time for the admin to approve your account, and your account should be in your name. Okay, so once you have put your account in your full name, then you press log in. You can see log in up. You press on log in to bring for you username, password. So username, they have already created my account, Madaraka. Okay, I put in my username, then I go to password. I put in my password. Then you can press remember password, or you just click on log in. Okay,
log in. Sometimes it brings such a display, can bring for you that please solve this math problem to prove that you are not a bot. Okay, that's not hard. Prove your humanity. 4 plus 2, you say 6. Then you continue. It's just simple. Then they tell you put in your username or email. Then you put it there. I've said you are ready, Madaraka. Okay, Madaraka. Then you put in your username plus password. You log in. Okay, when you log in, you get to the display, which is the dashboard. Okay, the dashboard is there. Brings your photo, but since you have just created the account, you don't have a photo. You can put it there if you need your photo to be on your account. Okay, so you want to bring such a display. You scroll down, you see dashboard, courses, activity, profile, notifications, messages, meetings, tours, friends, groups, forums, and settings. Then you continue going down. You see down your access classes: senior 2, senior 3, senior 6, senior 1, senior 4, senior 5, O-level, general. Okay, so what do you want? I think if you know your class, you should select it. For example, if I select senior 2, okay, senior 2, I'll be able to access all the work of senior 2. Okay, I will just scroll down and see senior 2 biology, and it's saying click here to access all the work. And click there, you see senior 2 physics, senior 2 English, okay, senior 2 history, senior 2 agriculture, senior 2 chemistry. Okay, so if I want chemistry, click on chemistry. Click on where is that word senior 2 chemistry, click on it. You'll be able to access another display. You see, you scroll down, you see course curriculum, notes and assignments. You see there is topics. Okay, oxygen. So if you want to see the topics, you click on the word topics. You reach there, you see topics. There are instructions there in red. Download the whole PDF and access all the notes. Read.
Right. So when you reach there, you'll get the work and you'll be able to use it. But what is important, read the instructions. If instructions are saying download and copy the notes, download and copy the notes. If instructions are saying download and read this work, okay, you just download and read. That means it doesn't require you to copy the notes. If they say download, read and summarize, for example, like English, okay, you can download, read and summarize a certain passage. Okay, so if it is say the instructions are saying download, read and do the assignment on page 7, do the assignment on page 7, okay, then hand in. If the instructions are saying read the questions and answer answer them there within, when you are still online, do it. Sometimes you have to scroll around and look for some of the instructions. They might be like time 20 minutes. So for you look at the question, you first be there doing other things. Time will keep moving, so you will not be able to do that assignment on time. Or even if you delay, it will disappear. And you access some of the assignments, you access them once. Okay, so you should be able to read whatever is around the work you access. So let us leave that one and go to our today's topic. We are going to look at mixtures. Okay, today we want to look at a different segment. We ended the other topic, so let us look at something else. Mixtures, and we are going to look at separation of mixtures specifically. Right? So if you can see what we are supposed to achieve in today's lesson, there are not so many things. We just want to achieve 2
things. One, we want to, by the time this lesson ends, please make sure that you are able to define an element, able to define a compound, and able to define a mixture. Also, make sure that you are able to describe the different methods used to separate mixtures. Alright? So that one is very good. So make sure you aim at achieving all those objectives. So let us look at what is an element. We can say that an element is a pure substance that cannot be split or divided into two or more simpler forms by any known chemical means. Okay? By any known chemical means. Cannot be split. Take note of that one. Cannot be split by any known chemical means. So those are some of the examples of elements. You can look at them. We have hydrogen, we have helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. I'm trying to read through these elements for those students who are there viewing the elements for the very first time. I know candidates are attending these classes, senior 3, senior 2, those ones I've seen them, but also there might be a brother or a sister who is in senior 1 and is attending also this lesson. So we need to read these elements so that they know how to pronounce them. We have sodium, we have magnesium, we have aluminium, we have silicon, we have phosphorus, we have sulfur, chlorine, argon, potassium, and calcium. Those are some of the elements we look at our level as far as olive is concerned. But as well, we also look at other elements. For example, you can see copper, we have zinc, we have iron, we have mercury, we have lead, we have gold, we have bromine, we have cobalt, and magnesium. Alright? So some of those elements you see, they are starting with the symbol of the element is the first letter. Okay? In some of the elements, like hydrogen, H is the first letter. Helium, you can see He, the first. Lithium, Li. So when you go to elements like potassium, okay, you find it is K. When it does not correlate with the what? The name. But those ones were just, they gave them names from the name, the scientific names, like carium. Okay? Had the name carium, so they gave it. Sodium, can see it is also Na. Okay? So with time, you go on learning those things. But candidates, you looked at all this work when you are still in senior 2 or senior 1. So when you go to our next slide, we see a compound, because you have already defined an element. Okay? So let us see a compound. A compound is a substance made up of 2 or more elements chemically combined together. 2 or more elements chemically combined together. The word chemically combined together is very important. Alright? The other side cannot be split into 2. That is an element. But here, you're combining 2 or more elements. And how? Through chemical means. So examples of compounds, maybe I've been looking at water and you don't know that water is a compound. And since you have said that a compound is made up of 2 or more elements, then you can look at the elements which are contained in that compound. Water as a compound consists of hydrogen and oxygen. When you look at carbon dioxide, it is having carbon and oxygen. Look at potassium permanganate. You can see there are more than 2 elements. There is potassium, there is magnesium, there is oxygen. When you go to lead to nitrate, you find that there are 3 also elements in it. There is lead, there is nitrogen, there is oxygen. Then oxygen gas has 2 elements. Okay? So you can see that during the formation of compounds, okay, chemicals combination of elements. Atoms of elements combine in definite proportions and energy in the form of heat or light or electrical form. Is either released. So those things, that's what we are seeing the other side. Okay? Heat of formation. So here we are forming a compound. So there is heat or formation involved. Alright? So those are the compounds you can look at. Some of them you have been interacting with them. Sulfuric acid. Someone will say sulfuric acid is a compound, and another person will say no, it is an acid. Being an acid does not stop it from being a compound. Just you should differentiate the two, or learn how to use them or to apply them. So having seen an element, we have seen that a compound is chemically combined. Okay? Then let us look at a mixture and say that a mixture is a substance made up of two or more elements or compounds physically combined together. You can say that a compound, we talk about being chemically combined together, but for a mixture is physically combined together. So when they bring a question differentiate between a mixture and a compound, you should be able to differentiate the two. And the other one, containing elements that are chemically combined, here they are physically combined together. Alright? So let us look at the classes of mixtures. Okay? So some of you have been seeing things they are there, but you're not sure whether it is a mixture. And some people know that mixtures are only, we only have liquid mixtures, liquid and liquid. That's when a person can, or liquid and solid. That's when a person can accept that this is a mixture. But you can see we have a number of them. We have solid, the solid mixture. So when you get copper and combine it with tin, you get a what? A solid mixture. When you get salt and combine it with sugar, you get a solid mixture. When you get sand and salt, you get a solid mixture as well. And with time, remember we said on our second objective, we are going to look at the methods of separating mixtures, right? So here we want to first look at the mixtures, but from here we are going to look at how we can separate these mixtures. Having seen that this is a mixture, what if I want one of the two? Okay? So you can see we have solid mixtures. Now we are going to liquid mixtures, right? We have liquid gas mixture. Now you go back to that slide. Yes, we have solid liquid mixture. For someone who is taking note, solid liquid mixture, we can mix sand and water to also be a mixture. Can mix chalk and water, can also be a solid liquid mixture. Then when you look at liquid mixture, we have ethanol and water, oil and water. You hear some of it that we have oil in Lake Albert. So it is a mixture. So they are going to separate, when refining, they are going to separate oil from water. Okay? And even we are going to see that even oil itself, it is having so many, it is a mixture itself. So they need to separate the components in it. So we have liquid gas mixture. You can see we have water and air. And sometimes you are walking and you feel like it is dissolving. So that water which is dropping on you may not be comprised of only water, but air also will be there. When evaporation takes place, it is not only water which moves into the atmosphere, also air goes with it. Okay? So finally we want to look at gas mixture. Gas mixture. You can see sometimes there is a mixture of carbon dioxide and oxygen. There is a mixture of nitrogen and oxygen. So when you mix nitrogen and oxygen, you get it nitrogen dioxide, nitrogen monoxide, right? So it is also a mixture. So let us, having seen at least a sample of mixtures, let us look at now how well we can separate the mixtures. How well we can separate the mixtures. Now we are saying that mixtures can be separated by a number of physical methods depending on the properties of the components. Remember, these mixtures are formed through physical means. Okay? So also you can as well separate them when you get sand and you add it into water. You do it physically. It is using physical means. But as well, you can also separate water from sand using physical means. That's what you have to look at. However, for you to be able to do that, you should look at the properties. Properties such as solubility, boiling point, and magnetic properties. So we're going to see how those properties are applied in different methods of separation, right? So we can see methods. We have decantation, we have filtration, we have centrifuge method, we have sublimation method, we have use of a separating funnel, we have simple distillation, we have fractional distillation, we have separation by a magnet, we have chromatograph. So some people say that, you say which method can be used to separate this one and this one. Someone said, and in the answer say distillation. You be specific. Which method? Is it simple distillation or fractional distillation? And sometimes they say that following which property, which principle is followed when you're applying that method. So the principle will depend on the properties: boiling point, magnetic properties, solubility. Alright? That is the one which will determine the property, the method to use. Okay? So when we move, we are going to now to start grouping these things. Remember there we are seeing them, there are many methods. We don't know which method is best for which mixture. So we are going to group the mixtures so that we'll be able to pick out the methods that we have to apply. So let us start with separation of insoluble solids from liquids. Separation of insoluble solids from liquids. Take an example of an insoluble solid. We have sand, and sand is insoluble in water. When you add sand into water, you'll be able to see that sand is there, water is there. Okay? You'll be able to realize that in this water there is sand. What do they mean by soluble solids? They are the solids you can add into water and you're not able to see that in that water there is a given solid until you start separating the two. Right? So in soluble solids we have sand and water. The methods you can use, we have decantation, we have centrifuging, or filtration. Those are the three methods we can use in this case. So when we begin with the first one, we see that there are a number of things we have to consider. So we are saying that the mixture, let us start with decantation on our next slide. We are saying that the mixture of the solid, which is sand, okay, and liquid, which is water. Remember, we are dealing with sand and water. So the mixture of the two is poured in a beaker and allowed to stand for a while. What you do, you get sand, you add it into, when sand and water they are there, you add them into a beaker. Okay? And you allow that mixture to stand for a while or for long. Okay? So the solid, this sand being denser, mean that they are more dense than water. So they tend to settle at the bottom of the beaker, while the water remains on top as it is less denser than sand. Okay? So it tends to settle at the top, the other one at the bottom. So what you do is that you carefully pour out the water, or you can pour it into another beaker, and in that beaker we remain with sand. Okay? So you can do it practically as a student there at home during the day. So let me apply this method and see if it is practically possible. Alright? For centrifuge, for it applies to only very tiny solids, and it forces them to settle at the bottom. A centrifuge is a machine okay, that you can use to force those small solids to settle at the bottom so that you can be able to pour out to the water. So let us look at filtration as number 2. Okay, centrifuge, we have talked about it using decantation. It is more related to decantation. Okay, only that for it is you use a machine because you are dealing with very tiny solids. So filtration, I know some of you have ever filtered something, and for those who have ever gone to the lab and did at least some practicals, you have been carrying out that, you have been applying that method there. You say during filtration, you say the mixture of the solid, I've said the solid, we have a sand. We have sand, and liquid, we have water. It's poured through a filter funnel containing a filter paper. So what you do, you get it, you pour it into a filter funnel containing a filter paper, right? So once you pour it there, the particles remain trapped in the filter paper, and they are called the residues. The solid particles remain trapped while the liquid passes through the filter paper and is collected in another beaker as the filtrate. Alright? What you get, what you trap is the what? The residue. What passes through the filter paper is the filtrate, and that will be the liquid, and the other will remain as the solid, which is sand. Alright? So the practical will be over. As well, you can try that one. You can use a cloth to carry out that experiment at home, and you'll be able to be successful. So we have looked at how we can separate an insoluble solid from a liquid, or from water, sand from water. Let us look at part B, where we are saying separation of a solute from a solvent. Okay? Separation of a solute from a solvent. So a solute, take an example of sugar or salt from water. So the methods used, we can be having evaporation method, we have simple distillation. Right? So once, if for a solid and a solvent, this is what we are going to deal with, at least a partially soluble or soluble solution. Right? So you cannot tell that now this is a solute, this is a solvent. They have already formed a mixture. You just look at a mixture. Alright? So what do they mean by a solute? A solute, for example, salt can be a substance that dissolves in a solvent, which is water. Then a solvent is a substance that dissolves in a solute. Alright? You just play around with the English. Then what is a mixture? Okay? A mixture we have already looked at. So a mixture will be comprised of the solute and the solvent. And in that case, we shall see it as a solution. Okay? So let us look at evaporation method. We have said that we are going to use two methods. Let us start with evaporation method. So evaporation as a method, we are seeing that the solution is put in evaporating dish and heated gently over a steam bath as shown below. You can see it. You can see we have evaporating dish containing salt solution. That means it is containing the solute and the solvent. Then you can see formed salt crystal. It will be there. Then you can see the beaker, the boiling water, then the wire gauge, the stand is there. Then heat is also there. Okay? So what do? You continue heating until when the water has evaporated. Remember, you are separating water from the salt. So you continue heating until all the water has evaporated. As the water evaporates, crystals of the salt are formed in the evaporating dish. We have showed you there the formed salt crystals. As they start forming, you see them. They tend to be bigger than the ones which have not yet lost the water. Right? So this experiment, it is not only in secondary. If you attended to a good primary school where they used to do practical science, so they normally they do these things in science of primary. Okay, those science teachers, science primary teachers, they normally carry out these experiments as a way of motivating the pupils, okay, and preparing them for secondary life. So when we look at simple distillation, so far we have looked at how many methods? 3 of them: decantation, filtration, and evaporation. So let us look at simple distillation. Okay? So distillation itself is the process of heating a liquid to form vapor and condensing the vapor to form a more pure solvent or liquid. Okay? It is just you undergo a process, you heat a liquid to form vapor. As that vapor forms, or as it evaporates, to pass through a condensing tube and form again a more pure liquid. Alright? So this method can be used to separate solids from solvents and for separating liquid mixtures. We have already seen what are the liquid mixtures, what are the solid liquid mixtures, whose boiling points are wide apart. What do they mean by wide apart? Okay, so our topic is mixtures. Okay, so when they talk about temperatures or boiling points being wide apart, mean that at least there should be a big difference in the boiling point. For example, when you look at ethanol, its boiling point is around 70 degrees Celsius. So when you are separating it from water, that one of water is 100 degrees Celsius. At least here there is a big difference of 30 degrees Celsius. Not mixtures that might be having, this one is 70 and another one is 75 or 73. These ones are not separated by simple distillation. As we shall see, what can be used to separate them. Alright? So we have started with simple distillation. I'm saying we are going to see what can be used to separate such a mixture with the components that are having very close boiling points. So we want to look at that diagram that you can, it is an experiment you can carry out. But in normal life, in real life, you have been carrying out distillation of alcohol in the villages there. Some people, or even in town, if you are able to carry out this, you can carry it out. Okay, if you have what is required. Okay, so you can see we have a thermometer is detecting the what? The temperature change. We have the wire gauge is helping that the distillation flask to settle there very well. We have the stand, we have heat, we are applying heat. We have the retort stand there. We have the condenser, I've been talking about it. We have the clamp stand to support the condenser, to keep it up. Then you have cold water. So in that condenser, there is what? Cold water, and it is running, continues moving. So when you are in the village, you can realize that when they are preparing alcohol, there is running water. So where they put it, the tube. Distillate, pure water is there also. Okay? So once you start heating the mixture which can evaporate fast. So there we are separating water, okay, from salt. Okay? Or you are separating salt from water. Which one do you want to state first? It is upon you. Because at the end you have separate
components. You remain with salt in the distillation flask. Then the other side you'll be having a distillate which is pure water. So that is the experiment you can carry out. So you can take note of when the mixture is heated, the solvent should be more volatile. Okay? If it is more volatile, it will evaporate fast. Okay? Then you condense it and be able to collect it. Then the solute, which is the salt, will remain at the bottom of the distillation flask. Right? You heat, the water will evaporate. Then the solute will remain at the bottom of the flask. Alright? That is how we can deal with simple distillation. Right? I'm just here to remind you about a few things you studied. Right? Then let us look at separation of miscible liquids. And what are miscible liquids? Right? I like writing this word because it is very important and confuses so many students when they don't understand it. It is common in papers. Miscible liquids. These are liquids that can be mixed together in all proportions, forming a uniform layer. When you mix these liquids and someone tells you that that is a mixture, you may not be able to accept, you may not even accept, you may not be able to tell that it is really a mixture. You may not accept, you say no, that is water. Okay? That is water. If you have mixed ethanol and water, if someone tells you that is water, you not accept. When you smell on it, you say no, this is only ethanol, which is alcohol. Okay? So for at all level, normally we term alcohol to be, we say that is alcohol. Whatever we see, it is alcohol. Okay? But when you go to organic chemistry, we shall call it ethanol. This is the normal alcohol you interact with. Okay? However, there are so many components of alcohol, as you can see. There is propanol. Okay? There is butanol. There is methanol. And so many. Right? So once a mixture is able, or once those liquids, so this one is a mixture of liquid, and they are miscible. They can mix completely, and they form a uniform layer. Okay, so we call them homogeneous mixtures. Right? So examples are there. I've seen them. We have ethanol, we have water, and the methods of separation, we're going to see that we can use simple distillation when the difference in boiling points of the liquids are wide. And as well, we can use fractional distillation when the boiling point difference of the liquids is narrow. Okay? As you have seen here, I told you that when the temperature differences are very close, you use fractional distillation. When they are large, you do what? You use simple distillation. Okay? So let us see an example that you can use to make sure that we explain our point. We want to look at the separation of a mixture of ink and water. Separation of a mixture of ink and water by simple distillation. Okay? So the procedure is there. You just pour a mixture of ink and water into a filter flask, fitted with a delivery tube to its side arm, and insert a rubber bulb carrying a thermometer to its top, as you can see in the diagram. Alright? You can see the rubber, you can see the delivery tube, you can see the thermometer, you can see the filter flask, you can see the ink that is containing water. Alright? You can see heat. So you start heating. As you heat, water boils at liquid, pure water boils at a lower temperature than ink. So you heat as you measure the temperature. You apply the thermometer there. What you do, you keep observing on the thermometer. When it's close to 100, water will start evaporating and leaving the filter flask.
as it moves, once the temperature exceeds 100, then you can stop the experiment. You have evaporated all the water. Right? That's very important. So, since we have looked at simple distillation, let us look at fractional distillation. Remember, I've said fractional distillation is for the liquids which have a very narrow boiling point difference. Okay? So we are saying this is a process of separating two liquids by using their differences in boiling point. Okay? So the liquids to be separated should be having different boiling points. It's very important. So if they ask under which principle does this method work, you have to put there that principle that the liquids to be separated should have different boiling points. Even if it's too narrow, this method will be able to separate the two components. So if you look at the example, we have ethanol and water. We have gases. We have petroleum. I've told you that what they do when they are refining petrol at the petroleum refining industries is that they use fractional distillation, or at they are in brewing industries. They also use the fractional distillation. So that can be the setup, laboratory setup of the experiment. You have the restored sand, you have the fractionating column, you have warm water, you can see it is going out. There, the condenser. Remember when the vapor is coming, it's trying to condense. It is trying to be condensed. That vapor, it is moving, flowing down, passing through the condenser. That condenser will tend to heat up. So what helps it is that it is put, that tube is put into a condenser that is allowing movement of water in and out as it comes. When it is very cold, cold water enters, but as well has to leave, move out from the other side. Okay, so that you keep the condenser cool to allow the cooling of the vapor. So what you collect down is the distillate. Remember, I have said from here, from this point, I've talked about ethanol having 70 degrees Celsius, water having 100 degrees Celsius. So what happens is that as you heat, as you apply that heat, this ethanol will evaporate fast. When it clocks to 70 degrees Celsius on your thermometer, okay, you will start seeing vapor moving up. That vapor will be comprised of ethanol. So as the vapor goes on and the temperature is kept there, when the temperature starts to increase to 72, 73, you see a stoppage in the evaporation. So you should be able to observe that now ethanol is over. What is coming next is water. You stop the experiment, you remove the ethanol. If you want to make this water also be pure, you can allow it also come. You put there another beaker, you collect the pure water as well. So that you deal with two pure liquids. Alright? So that is the apparatus, and that's how we can deal with the experiment. So I've said that we are going to be moving on with so many things. Then let us look at applications. I thought about it and I said these applications are very important. Right? How is this method applied? Applications of fractional distillation. On our next slide, that one. It's used in the brewing industry to produce quality drinks such as beer, whiskey, and distilled water. Okay? So it's used in the oil refining industry to separate the different components of crude oil. For example, kerosene, diesel, and petrol. They all come from the same industry, but you'll be able to have oil alone diesel alone, petrol alone. There are those vehicles which don't take in diesel. So if you apply their petrol, you will spoil their engines. So that is the importance of this chemistry. When you study it, you'll be able to, they will employ you there and you apply the chemistry. Also, it is used in large-scale manufacture of oxygen. Okay, remember I told you it is used to separate gases. Liquid air can be fractionally distilled and its components separated. Right? So let us move on and see now use of a separating funnel. Okay? We can see something else which is use of a separating funnel. Okay? There. We are saying that we have to separate the immiscible mixtures. Remember I've talked about miscible mixtures. Now we want to talk about immiscible mixtures. These are the heterogeneous mixtures. And we say that a heterogeneous mixture is a non-uniform mix of two or more substances. In this mixture, they form, it tends to form two layers. Okay? When it forms two layers, you can be able to see that there is a layer up, there is a layer down. Alright? So a mix of oil and water, paraffin and water, and so on. Let us look at the separating funnel on our next slide. We are seeing that there is use of a separating funnel. And this one is used to separate liquids that do not mix at all. Right? You can try this at home, get oil, put it into the same beaker or same cup with water. You'll be able to observe. Get a glass. Just is for observing. Get a glass. Because you may not be able to get that machine. Not be able to set up such an experiment. We shall do it when we are in the lab. Okay? The separating funnel may not be there at home. So what you do is you apply the experiment as shown there. Let us go to our last slide. Let us look at our last slide. The last slide. We are saying that we have been moving together from Monday, from the other Monday. Now we have taken 2 weeks. We have looked at chemistry, but without God, chemistry also might perish. And it even may not enter into your head. If it enters there, it may not be of any importance. So we are saying that look at Psalms 9, chapter 9, verse 9 to 10. It is saying that the Lord is a refuge for the oppressed, a stronghold in times of trouble. So you can remember that the stars might fall, but God's promises will stand and be fulfilled. Okay? So allow me appreciate you for being with us. I know you have been there, you have sacrificed your time to view us. Even parents are there, encouraging their students or their learners to learn chemistry. Lessons are going to continue next week. I've been Saul Abooki. Have a good time.
Television, your family network. It's happening again this Saturday. Yeah, you heard me right. The newest edition in town is back. The 5th edition of the Lockdown Charity Concert at Christian Life Church, Makerekavle, Bamboo Road, from 4 to 7 p.m. Don't miss your favorite gospel artists: Holy Ken, Damasco, Carlifex, Pamela Senyonga, Mugabe David, AD, Lady Carol, Henry Wamala, Joyful Generation Dancing Group, and many others. Hosted by Joshua Senyonga and the President of the Federation of the Gospel Artists in Uganda, His Excellency Lon Mek. It's going to be live on Top Radio, Top TV, and our Facebook page, Pastor Jackson Senyonga. Don't miss this Saturday.
Are you looking for land with access to water, electricity and social amenities? Look no further. Zion Estates has got the biggest, most secure and well-planned estates in Uganda. We offer flexible payment terms on all our plots. So why keep renting? Find us at Zion Building 2nd floor, Chibuye and Tebe Road, or our branches in Boise. Zion Estate, your home, your prestige.
The entire population will put on fabric masks, which are good and very protective. When getting out your mask, you must ensure that you have sanitized or washed your hands with soap and water. Now, when you pick out your mask from the safe place, you hold the loops and you flip it over. Make sure your nose, your chin are properly covered. Do not share masks and do not pick any mask that you find dropped on the way or anywhere in your surrounding. Avoid buying masks where people are allowed to try on and return.
This message is brought to you by Ministry of Health, supported by Precision Media, UNICEF and World Health Organization.
Life Day and Boarding Primary School ly'essomero eryazimbibwa ku musingi ogw'okutya Katonda nga tusomesa abaana okuva ku nursery okutuuka ku P7 era nga tulina ebisulo eby'omulembe. Essomero lyaffe lirina buli ekyetaagisa okuyigiriza omwana wo nga library, computer lab nga kw'otadde n'abasomesa baffe abatendeka obulungi. Tubangula abaana mu by'emizannyo era ng'enjigiriza yaffe eri ku mutindo gwa nsi yonna. Tulina clinic era nga mulimu omusawo omukugu omutendeka obulungi. Tusangibwa Bajjo, kilomita 4.5 nga wakava ku Jinja Road mu Trading Center y'Ekigunga. Okuwandiisa abaana kugenda mu maaso, tukubire ku simu zino